Hey everyone, I'm David Room. I've got something planned for tonight that I'm pretty excited about, something that I've been wanting to do for a long time. It's been on my backlog for a long time, but I haven't really gotten around to for various reasons, and that is adding glowing bits of detail to the drives on my ships. So, for people who might be new to watching, I have a process where I'm using uh, programmatic modeling using the Python programming language to do low poly and higher poly models of spacecraft from my fictional universe. And something that I started thinking about as I got into making, especially game graphics, is that these ships really should have glowing drives. My spacecraft in my fictional setting do not have rocket engines like hard sci-fi or probably most other sci-fi depictions of spacecraft have some kind of, you know, rocket or jet engine type um, thing that is giving it thrust. My ships use some kind of currently unknown principle that turns energy basically into reactionless thrust. Maybe something more like a warp drive from Star Trek, but I think just for various reasons, I think it would be good if there was some glowing detail on the drives. And also, there's a unique thing that I can do is put glowing detail on either side of the drive because the drives kind of have ends. And also, there's thrusters and other little details that might have that same kind of glowing detail on bigger ships. So, what I'd like to do today is kind of go through the whole process of modeling this stuff. We're going to build up some uh, functionality for modeling two-dimensional arcs with a certain thickness because that's the shape that these features of the drive are going to have. I'm not actually, I might have that functionality already, might have to find it. If I already have it, if I don't have it, we'll build it. We will update and get these markings in the data structures for the game for at least a couple different ships, and maybe get as far as actually working some with the materials for the game as well. So without further ado, let's get into it. I'm going to put on some music and let's see what we can come up with. Getting kind of a late start, but I am anxious to make some headway on this problem. And something that I've seen is the longer that I tend to go. So if I stream for longer, I tend to get a few more viewers. And it seems that one of the ways that my channel grows the most readily is by live streams. So we might go a little longer than usual tonight, because I kind of want to take this beginning to end and see what we come up with. So I've got my coffee, I've got some water. We're gonna get settled in here. I see Doug Wise is here. Hey Doug, it's always good to see you. Are you working on anything interesting tonight, Doug, or just hanging out? I really hope sometimes that these streams might motivate other people to work on their own cool projects as they are listening. Oh, hey Jersey, good to see you again. We're just getting started here, adding some cool details to low poly models. So let's take a look first at what the current situation is here. We'll bring up some ships in the game engine. Whoops, I'm in the wrong folder. Not even in the code folder. Okay. So the current, I left that in from a screenshot that I was taking. I'll get rid of that actually before we go on. Okay, so the current situation is we have all these ship models, and they have various types of drives. Mostly they're these long cylindrical things, and they don't have any kind of glowing bit on them, either front or rear. So the current sort of emissive materials on my ships are the radiators and glowing windows, and I actually only have windows on a couple ships. So I think adding glowing drive bits will add a lot of interest to these models, even if it's kind of a dim glow, which is how I imagine it. I don't imagine the drives glowing very bright, or maybe the brightness varies as the acceleration that you are asking from the drive changes. Oh, nice. Doug says he's not working on any exciting projects, but he's listening while he does general maintenance, like backing up files. I have to do that, some of that stuff every now and then too, and it's always good to have something nice to listen to. Jersey asks, are these ships better than SpaceX Starship? Well, they're not better because they're not real, but they are certainly more fantastical. And you know, something that I've been meaning to do, and this actually would be another good thing to do on a stream, is actually make a model of Starship that is to scale with these, because it would be interesting to put it in the lineup and see for a size comparison. I think it's actually around the same size as some of these bigger ships. So yeah, some of these smaller ships, you know, only one end of the drive is exposed, so like for these we wouldn't need to add glowing bits to the other end. For some of them, not the entire surface of the drive is exposed, so we'll want to make different shapes. For this one, it's like a large ring rather than smaller drives, so there's a few different variations of things that we want to do. Yeah, so let's get into it. Oh, and then just one other thing I was going to show. I did start modeling this out a little bit in one of the high detail versions of the ships. So we can see what that kind of looks like here. Oh. So here's the high detail version of the Sayuda, and let's just take a look here. So eventually I would want to carve out the inside of the drive, but here you can see in the cap I have these two slits, and the in-universe reason for this would be that the way these drives work is they actually have like a spinning thing inside. called a entropy mesh. I don't have like a very good explanation of why exactly it works, but it's basically a device that takes a bunch of electricity and spins and then produces thrust somehow. And the effect that it produces, it kind of works on this layer of reality that sits behind space. So it doesn't need to be exposed necessarily. It can be, it can have a covering over it and it still works. But it could be that there's some laws or things that kind of govern how the flow of this layer behind space works, and that for certain reasons you might want to have openings or different things like that. And if there were openings, you would see the entropy mesh, and it might have some kind of, because it's sort of a magical, mystical thing, right? It might have, it might glow, right? And I have a couple other sketches here that I just want to show too. So, some sketches that I did in my church bulletin of what some details might look like. So just kind of these arc-shaped openings is what we're going for here. All right, so let's dive into it here. The first thing I gotta see, and actually let's think about what ship we want to work on first. Let's actually work on the Hammond, because that's the one that I have in the thumbnail. People seem to like that ship too, and it's one that's been neglected a little bit lately. So here's the Hammond, and you can see one thing about viewing things in here is that it doesn't show these markings that are kind of coplanar very well, but we can still see them. Yeah, so Jersey says in space, if you spin, you don't produce thrust, but you have because you have vacuum. But I guess this project is not quite about physics. Yeah, it's not like a turbine exactly. It's more like the idea, and I can just share some more details as far as I've reasoned it out. The idea is kind of like is that there's sort of an effect where if you, and this might be something that's in other sci-fi worlds, I'm not sure, but the idea is like if you do certain kinds of things in the world, it's like too much for the universe to compute. So weird things start happening, like with gravity. So the idea is if you pour a whole bunch of electricity into these little relays, and then also move those relays through the sort of local region of space very fast, and you do that by spinning, then it starts generating this kind of like pseudo-gravitational effect that can actually pull or push the object that's generating that. So it's not like a turbine, it's just like a rotating ring. It's not really pushing against anything, but it's generating this effect. That's one explanation I have for it. Another thing I'm thinking about is like there is something like water or a fluid that sits behind space, and this drive can kind of, you pour enough electricity into it and have it do certain things, and it can kind of start engaging with that that fluid. So it's doing something like that. And Skunk's Workshop asks what class is the Hammond. So the Hammond is a Corvette. So it's like a small, it's a small ship that would be like two, maybe 3 or 4 people would operate. In my setting, ships have pretty small crews because everything is computerized. You don't need big crews. And Skunk's Workshop says so. It's bending space-time basically. Kind of, yeah. It's more of a. It's not really like a relativistic bending of space-time. It's this this stuff called the ether that shows up in my settings. In my setting in more fantastical ways usually, but I figured that it's related somehow to how drives work. Okay, so what we're going to try to do is we're going to try to make some flat structures that are going to sit here on the front and rear of these drives. And then we're going to use the same techniques that we use to do the window markings that are glowing to make those pieces glow. So that's our approach. And Skunk's Workshop says really cool, bro. That's awesome. I'm glad you think it's cool. A lot of this stuff is just kind of like second nature to me since I've been thinking about it so long, so I have a hard time judging whether other people will find it interesting, but I'm glad that you do. And it's fun to be able to share it with people who think it's interesting. Okay. All right, so let's get into this. So here's our function for making the Hammond. We're basically building all of these parts and then putting them together. We're probably going to want to parent the glowing bits to the drives. So it's going to be one of these parts that'll become the parent. And then here's where we put everything together into the part set. So Skunk's Workshop says, I'm still hoping to come up with merch one day. I'll buy each one, no hesitation. Yeah, well, that's the intention, but I want to have some things. I want to have a set of I have a set of things in mind that I want to have before I start trying to sell individual bits and pieces. So, but that is the goal. I think stuff like merch is fun. I know some people are just like, oh, you should just write books or make comics or something. I love I love toys and little knickknacks and stuff like that. So that's something that I'd like to make. Plus, it's fun to have physical things. Okay, let's just. Take a look at the drives here to get reoriented. Yeah, so there's our two drives. Let's yeah, we'll just call it drive glow. And I guess we'll probably spin these too. So spin is a function that I have for setting things up. So, oh, nice. Let me just review how the spin function works. Oh, nice. Nice. Perfect. Perfect. Okay. So I'm just parameterizing the shape that I want the glow to have here. I'm going to start out just with the circle, make sure everything's lined up, and then we'll go from there. Okay. See how many subdivisions I have here. Drive subs, okay. All right, so that's going to be a disk. Oh yeah, that's just a circle actually. That's funny. I don't actually have a I don't know if I have a primitive for just a disk. That's kind of funny. Box, torus, quad. I guess I don't. That's funny. Okay. Well, so this is our circle, and we can just triangulate it. Yeah, just let's triangulate poly. And I think this is expecting something 2D. But, and actually we'll just use our rib convention here. And we'll attach. Okay, and let's take a look at this. Now, what we're going to want to do is we're going to want to spin this, and there's a few different ways we can do this. But we'll just do this separately. So we'll do a front and a rear. So we're going to spin the glow mesh. Oh, actually, wait a second. We don't need to spin this. We could... I'm not thinking. We can just parent them to the drives. And I think spin just uses... It just adds a prefix or a suffix of the index, so that's easy. Man, I'm too far out of this low low poly stuff. It's way it's way easier than I'm picturing. Okay, so basically we'll just make a dictionary here for index in 0 and 1. For side side and normal in front is going to be so we'll have front and rear. Then we'll make our part is just going to be parent equals drive index. And see, I could just write everything out here, but the nice thing about writing it like this is that this will be almost copy and paste to take it over to any of the other ships, because most of them have these spun drives or drives that are numbered like this that we want to enumerate over and do front rear. Okay, so that's the parent. The model is going to be glow mesh, and the transformation is going to be just a where the translation, we'll just use translation, is normal times drive len divided by 2. Because the center of the drive is going to be right in the middle, so we'll offset forward, offset to the rear based on this normal, right? And then the key is going to be the key is going to be index and then side. Skunk's Workshop asks, I got here about 10 minutes late. Did you say what you're calling this kind of drive? Yeah, so I haven't said it in my books. I call it the general technology, it's called a Minkowski appliance, but usually they're just called M drives. So there's like M appliances, which are used for shields and gravity generators, and then the application of technology to drives, they're just called M drives or drives. So I don't really call them engines because they're not like, they're not like typical engines that burn something, and they're not like rocket engines. So I call them drives. And drive kind of indicates, it has that connotation of something is spinning, right? I think so. That's what they're called, M drives. Uh-oh. Okay, I thought I lost the broadcast there for a second. Looks like it's still going. Okay. So there's the part. Now let's take a look. So if we So there will be the drives, and then here will be the drives with the glow. Oops. So there's the glow. It's gonna, I see right away we're gonna have a problem because it's facing the wrong direction. Hey, how's it going?
Good, how are you?
Good. Are you heading for bed?
Yeah.
All right.
I brought this down because
Oh, thank you. All right, well, you have a good night.
You too.
Okay. Yeah. Yep. So they look like you can kind of see the Z fighting there. So it looks like they're in the right spot. But they are facing the wrong way. And you know, they really shouldn't be facing, well, there's some orientation issues that I need to work through with a lot of my stuff, and I need to think about it. Luckily it's pretty easy to just fix it by flipping it, so we're gonna do that. Okay. But we want something a little bit more complicated than just flat circles. That doesn't look too interesting. So let's just go for the complicated thing that I'm picturing, right? Which is these arcs. And I think good. I have it already. Look at this. It's kind of fun. When you've been working on a project for 3 years or so, or 4 years, you build stuff and you actually forget that you built it, and then it's a pleasant discovery when you have it. Like the other weekend when I was working on the bridge looping functionality, I wanted to triangulate in such a way that the triangles were convex, and I was like, oh no, I gotta write something that checks whether a pair of triangles is convex, but I actually already had it and I plugged it in and it just worked. So that's fun. Okay, so, and let's just take a look at this and see if it is doing what we want. I remember thinking a lot about this beveling. Oh yeah, this is really fancy. This beveling stuff. I think I would write this differently now. But this feature without the beveling is basically what we want. So we're going to go ahead and use it. Okay. So let's add a couple more parameters here. So we've got our glow radius, our thickness, we want probably either 3 or 4 separate arcs. Let's start with 3. And the arc gap will express in radians. So should be pretty small. Something like tau divided by 64. So a gap between each piece of 1/64th of the angle around the circle. Okay, so here is our initial thing. plus arcs. And what does this return? Does this actually... Oh yeah, it just returns a sequence of vertices. Oh, nice. And this is actually straight up in primitives 2D, so I don't even have to... Okay, so for in range of dry flow arcs and arc equals P2D. Actually, we'll call this rib P2D.arc. Arc double is what we want. Radius A. The radius B is minus thick. Start angle equals, now this is where we've got to think a little bit. So, and when I write up this kind of stuff, I like to not get too clever with it, but just write it out in a way that makes sense. So we'll be starting from, and I think this handles, I think my arc stuff handles, yeah, it should handle negative stuff just fine. So start angle is going to be tau divided by the arc count divided by 2 plus the gap divided by 2, and then the end angle is going to be and we've got to add our offset here as well. So this will be our offset. We'll call this offset. So this is going to be index times u dot tau divided by dry flow arcs, and then the end angle is going to be start angle. Actually, let's just repeating myself a bunch of times. Frac equals this angle. Frac. Okay, so offset is minus angle frac divided by 2. This is going to be angle frac times index, or offset plus angle frac times index, and then this is going to be start angle plus angle frac minus. Actually, and then let's actually move this here. Offset, yeah, okay, that's nice and symmetrical and clear. That's not start end angle, it's just end angle. Okay. Oh, nice. Okay. So we don't even need to do this end angle thing. We just need to do the total angle. So angle frac minus. And this is actually isn't going to be... it's going to be just minus the gap. Because if we're starting from half the gap... Yeah, okay. Cool. So angle is angle. And I think we'll be able to see pretty easily whether we've done this correctly. If there's any weird asymmetries or anything in it. Okay. And then bevel amount is going to be none. And then we're just going to, for the subs, we're just going to drive subs with integer division by our number of arcs. So basically the low poly arcs that we're building here are going to have the same number of subdivisions across all of them as the drives. I think this will look good, and if it doesn't, you know, we could like add a factor of 2 here or something like that, and I think that would look good as well. Okay, so now that we have our rib, we got to triangulate it. Oh, nice. Jersey says he needs to drop by, and happy coding. Hey, thanks for stopping by, Jersey. It's always good to see you. Okay. So, yeah, basically the same thing here. And then I have no idea if I was keeping the same convention here with the Arc2D stuff, whether we'll have to flip it or not. So let's just take a look. Oh, actually, yeah, no, we don't want to mesh. So let's call this meshes. Mesh, and then glow mesh is going to be mu.cat arc cat meshes. Alright. Okay, and let's just exit here and see if this looks like what we expect. And just preemptively do some debugging. Loop 2D rib. Yep, okay, so that's more or less what I was expecting to see. Yes, that's nice. It's fun when you write something and it does what you want. That's pretty much what I expected to see. I think I was expecting it to be a little bit thicker. Let's bump this up to 0.3. Yep, and it looks like we're gonna have to flip it. I think my convention is right. I have to think about the handedness of it, but basically we want a convention of things that go counterclockwise. Yeah, and this is correct, right? You can see the counterclockwise nature of it. So okay. So I know you've been watching a bit Skunk's workshop. I I sometimes wonder how much I should explain of what exactly I'm doing, but basically for anybody who's watching who hasn't seen before, I'm doing this low poly modeling, and usually I use a technique where I build up the outlines of things in 2D, and then I triangulate a mesh in between them, either like in a plane like this situation, or I use the terminology rib, like a rib of a boat or aircraft. So I'll kind of make cross sections of things, and then I'll triangulate from one to the next, add endpoints, and build meshes that way. So that's the general approach. I'm building some other ways. There's other ways I have of constructing things too. So I can also build surfaces by slicing, like booleans, things like that. I like to generally build the main shapes kind of constructively though. So that's what I typically focus on. Okay, so we definitely do want to flip. Bases. Okay, and I think everything actually looks good here, so let's get rid of this exit and see how they look on the drives. Yeah, you can see there, the faces now are facing in +Y. Okay, let's actually bring this into Blender because I can't see. It could be that just things are thin for some reason. Just doing a little debugging here. Oh yeah, there they are. I must have just quit out of it before I turned wireframe on the actual things. Okay, they do look like they're lined up. Let's still look at it. Oh nice, so the Cloudx says you have a very well-worked talent. Keep improving your talents and always walk with God. Seek him. He loves you and created you for great things. God bless you and your family. Hey, thanks, Cloudx. God bless you too. Yep. So those are basically basically just what I want. Now, and see, this is the advantage of parenting. I think given the way the drives are spun, we should have the glow should be symmetric. Yeah, so like the gap is, let's make sure people can see. The gap is facing on the inside here. And then the gap is facing on the inside, so that this is actually really slick the way this works. I think maybe I want a little bit smaller radius, so the problem with the way I'm doing this is that, well, there isn't a super straightforward way to calculate how big that... Actually, that's something that I might be able to work out pretty nice, actually, but there is a... with the bevel that I'm adding to the drive, it's not in one of these constants right now what the actual working radius that I have is, so I'm just eyeballing it, but that's okay. It doesn't really have to be a nice even multiple of anything. Yeah, that's a little bit better. The great thing about this approach too, right, is that it's, you know, you can... It's constructive. It's non-destructive. I can experiment with different looks easily by just tweaking things. Okay, now that looks like it might be facing the wrong way. Okay, so the Cloud Deck asked, thank you, by the way, what are you working on? So I am working on low poly ship modeling for my game. So I'll just bring this up, and this might be interesting for anyone who's joined us. So here's some of the ships from my game in engine, kind of a style that's based on games from the mid-90s with some modern rendering techniques. And what I'm working on doing is adding glowing drives. So the drives in my fictional setting don't use rocket engines. They use something more like warp drives. And I want to add little glowing bits to the front and back of them to kind of act as a visual marker, even though they're not like burning rocket engines. So I have other glowing bits on the ships, radiators, windows, things like that. So we're kind of going to extend that now into the rocket, or not rocket, but the drive details. Okay, so what's going on here? I thought we flipped things. Let me double check this. It could be just the... Oh, nice. Thanks. Thanks, Cloud Deck. Are you into game development at all? I'm curious about how you found the stream and what brings you by. It could be that just the Z fighting is not showing the... Yeah, see, this is facing... Oh, I know what's going on. Yeah. Okay, so here's what is going on. We can't just use this normal. We also need to add an additional rotation if they're facing backwards. So this is fun. So here in our transformation, So if side is front, we'll keep them facing the same direction. Otherwise, we want to add a 180 degrees around the z-axis. Yeah. And then if we click on these in Blender, we should see the, yep, the y-axis is facing out here. Nice. So Cloudx says, thank God I'm currently working on a video game development team. I'm looking to make it something completely official. Nice. So you've got some game development stuff in the works. Cool. I don't have a team. I'm a solo developer, and I kind of like it that way. I like just having it be a hobby and having me be in charge of everything. I work on a team at my job. I mean, I think everybody probably works on a team in their job, and it's nice to have something that is just I'm completely in control of. Okay, so we've got that worked out. And I'm actually going to flip this around. You know, here's something that's overdue. I feel like every time I stream, I'm talking about why don't I have an identity for, or a constant for identity. So let's add that in. Actually, we can even call it rotation identity. Let's see what I want to call it. Doesn't matter. This is gonna be, it can easily be renamed later. And let's add one in here too for good measure. For people who don't know, we express rotations as matrices. So you have a 3x3 matrix for a 3-dimensional rotation, and a 2x2 matrix for a 2D rotation. And this I is like numpy.I is how you specify an identity matrix. So that's a matrix that basically leaves the thing that it's transforming unchanged. So if we don't want any rotation, we just use an identity matrix. So CloudX says, I don't work for an established company or anything like that. I'm on a local team, me and 2 other guys so far. But I look to take it to a company soon, God willing. Nice. Yeah, I sometimes think it would be fun to have some friends to do some kind of game development work with, but I do enjoy the people that I work with in my day job a lot. And I like having something that's just purely my own. So I think it would have to be a pretty compelling thing for me to discover to join a team. Then I don't have a lot of time, so it's hard for and I really like my own projects. So any amount of time that I'd be working on a team with other people would be time that I'd be giving up out of my own projects. Maybe someday, if I actually finish some of this, maybe I would look for some other things to try, but we'll see. Skunk's Workshop says it really is fun being on a dev team. Yeah, I mean, some of the best times in my life were working with people at my job, and some of my best friends in life were people that I worked with. It feels really good to be working together with other really competent people on something and kind of playing off each other's strengths and weaknesses, and yeah, some of the best times of my life. Not game development stuff though, just other applications of software and machine learning stuff is kind of what I do in my day job. So okay, so we've got that in. Let's use this now, so we can do mu.identity3, and let's see if this still runs. Why is my root upside down? Oh. That was weird. Okay. Alright, this all looks good. So let's get this into the model. Okay. Or get it into the game, rather. Okay. So this is all debug stuff. Comment out. Get rid of later. Get rid of our original test stuff. Nice. Let's do some quick cleanup here. Oh, nice. Okay. So I want to look up now. Oh, nice. So leaf.wave says, so he's a comp sci student reporting in to ask a very important personal question. Do you prefer tabs or spaces for indentation? So I can give you a very comprehensive answer to this. And my answer is it depends. So different languages have different conventions. Python, uh, in Python, white space matters, and generally the convention is 4 spaces indent. So the way my editor is set up is like when you press tab, it just puts in 4 spaces. But there's spaces, not tabs. Like right. So if you start arrowing over back and forth, you can see that there's spaces. Now in other languages that don't have that as an established convention, I probably prefer lesser indent. Yeah, and Leaf says it gets nippy at you if you mix tabs and spaces in the same file. Yeah, it's really good. It's not good when you're using Python to be inconsistent about how you're doing spaces, even though you can be. For other languages, though, I prefer something like I probably would prefer to actually use tabs and then set the tab to be maybe 2 spaces. I think I do a lot of work in Notepad++, and I think the way I have Notepad++ set up is to basically have a tab be 2 spaces. I think, yeah, so it kind of depends. Like for text, I think I would just have the editor convert tabs to spaces and just use 2 spaces. But other languages maybe use tabs but set them to something like 2 spaces for display. That's a good question, though, and yeah, I think it depends is really the best answer. What do you prefer? He says, yeah, that's totally fair. Thank you for indulging my curiosity. Yeah. So what do you prefer? Do you have a tabs versus spaces preference? So I'm just looking here at our windows, because we're building some vertex colors for the windows here. I'm just reminding myself of the conventions. Okay, so Leaf.wave says, I'm a tabs person, but it's a mundane thing for me. And Softbread, also in the chat, says tabs for sure, in my case. Nice. Yeah, I think I initially used to prefer tabs, but Python kind of brought me around to preferring spaces. I mean, nowadays editors are so good about converting between different things, it kind of doesn't matter, right? If you can easily convert between 2 things or 2 different ways of doing things, it kind of doesn't matter. You know, like when you're writing your code, the refactoring tools are so good, you can easily rename just about anything in the code base. So it kind of takes some of the stress out of thinking about what you want to name things, right? Okay. Let's see here. And let me just check something else. I don't think I want to use... Actually, I could give the glow a little bit of a gradient. I don't think I'm going to do that right now. Let me see if I've got a function for... Yeah, it's just repeating it. Okay. Oh, are these... Yeah, okay. Ah, man, I'm out of this low poly stuff. Way too far. I have the capability to both give things colors by vertex or by face, and I think I'm just gonna use vertex colors here. So, oh, the Cloudix says, well, I'm leaving now and have a great night. Much success with the development of your game. Anyway, nothing is a coincidence. God allowed the first message to reach you. Bye. Yeah, thanks for stopping by, Cloudix. Hope to see you again sometime. Okay, so and eventually we'll do something more we'll do something more sophisticated here for this, but I actually really like the idea of doing a color gradient, but I think we'll save that for another time. Okay, so Softbread says making a game without engine seems cool, but incredibly tedious. So I am actually using an engine. I'm using an engine called Panda 3D, which is an older engine for Python. I'm not really using the engine right now because I am making assets for the game. So I'm using numpy and trimesh and some other tools and a library that I built myself for 3D modeling with Python to make the assets. But the game itself does use an engine. It's a pretty, I think it probably does a lot less for you than modern engines does, but it does do quite a bit. And I think I think before I started using it, I was thinking, oh yeah, I could like build an engine myself, but there's definitely a lot of stuff that an engine gets you that I wouldn't want to think about writing myself. Let's take a look at the window color here. I don't want to use exactly the same colors as the windows, but I want to use something similar. Softbread says, yeah, haha, it's so much bare bones compared to modern engines that are their own entire program. Do you have experience with Panda 3D? And Suscular says, what type of game are you building? I'm building a space combat game. Let me actually show you a little bit of what it looks like. Let's see here. So I'm not sure if I have any combat scenarios working like right now, so I won't show you those, but this is generally what the game looks like. Oh, thank you. I've put a fair amount of time into getting it to look a certain way, and it's definitely not anything off the shelf. So I appreciate that you like how it looks. And Software says, yeah, I've seen some videos here and there, but never used it. I'm assuming about Panda 3D. It's not something that a lot of people use. I was drawn to it just because it seemed to be kind of Pythonic, and I like Python, and also it seemed to have good documentation. Um, it does have good documentation, but there are some bugs. There's a really tricky bug with shadows, and I ended up kind of implementing a lot of the shadow stuff myself in kind of a annoying way to work around the bug. So I can't say I recommend it, but it is a nice engine for experimenting, and if you like Python, I think it's pretty nice. Suscular asks, what games have you made before? Not a whole lot. So when I was a kid, I kind of learned to program by making games. I made some text adventures, and I was building a Japanese RPG, like a Super Nintendo style Japanese RPG when I was in high school. This is the first game that I've really made as an adult. And it's more of an ongoing project than something that I need to finish. Softred says it reminds me of when I used to play Elite Dangerous. Yeah, it's definitely that type of game where there's sort of Newtonian physics with the flight control system. The combat is pretty cool too. Still kind of working on balancing and figuring out exactly how a lot of that stuff should be implemented, but I have high hopes for it being a pretty compelling experience when it's done. I think, I've done enough work that I have control over the right parts of things, that I'm confident that I'll come up with something that is, compelling in its own way. Okay, so we've got the color, and we've got our vertex colors. So we just need to add these now to a property. Yeah. So, and we also need the markings property. So props. So marking property makes it so that these shapes will be rendered kind of on top of other things, so they won't fight with the surface like we see when we use our debug visualization. And vertex colors equals what we see. Okay, so now we want to export everything, and then we'll modify the game files, load it in, see what we have. So this script actually generates and exports all of the models in the game. It runs that fast. It's great. Really makes me happy. And now let's see. Actually, let's just get this set up so that it will start with the Hammond when we start our ship viewer. And it does. So now we just have to add those markings in. So I have a convoluted system for describing the game data with YAML. I feel like this is a must for any project. So these are children of the drives. So okay, nice. So I can actually just add the glow here. So let's just make sure that I named these correctly. Glow, let's see, side, front, rear, okay. So now I just need to add an entry here for each of these with the radiator material, because radiator just does emissive material using the vertex colors. Eventually, I need to make a material that doesn't use the vertex colors directly, but maybe uses vertex colors to scale, or you know, do a linear interpolation on a couple other colors with a driver attribute. So I can do stuff like animating a glow changing with some parameter. That's probably too involved for tonight. I'm fading fast, but I think that's what it'll take. So want to go down here by the I think radiator is capitalized, right? Yeah. Okay. Okay, let's see what this does. Fingers crossed. Oh, heck yes. Look at that. Nice. Okay. So that is basically what I was hoping for. Let's take this ship out for a spin in the game engine and kind of see how it looks under game engine-y like flight circumstances. And let's see here. And then if this looks good, we'll actually go through and add this to maybe a couple of the fighters. Let's see here. I've got some weird mode stuff going on here. It's screwing with things. Okay. Okay. Here we go. So okay. So let's swap our Hammond in here. So all the missions and different stuff for the game are just described with code. Because why not? And what's the... It's just Matt Great New. Matt Great New. All right. Let's take a look. Okay, camera needs to be farther away. Oh, and we've got some... So do you see that flickering? So there's something going on where there's either... There's like duplicate stuff. I'm not seeing the flickering anymore. Could that have been something else causing that? Oh yeah, there it is. This looks really cool though. This was definitely a good choice. Oh, man, I really want to see them. I want to see the glow change, depending on my acceleration, though. Yeah, okay, so we gotta figure out what's up with that. I don't think... Sometimes when you're like perfectly aligned with an axis that the sun is shining on, you get these kind of flickery effects. But this is something else. Maybe I'm forgetting a marking property somewhere. It's a little odd because I didn't see that at all in the ship viewer. It's true. Marking plus true. It's probably something... Oh, I know what I did. No? Glow one. Auto children excludes. Oh. That was wrong. I don't know if that would have solved it. Let me see here. I haven't worked on this enough. I'm forgetting all the keys. I made the mistake of changing all the key bindings like right before I set this project aside for a bit. See, I think M is still map mode. Okay, so I'm not seeing any flicker on the front. Now that is odd. I don't see any... I don't see any flicker in the external view. So it is something... It is something to do with the ship itself moving, I think. Let's see here. What could cause that? That's odd. I wonder if the windows are doing that. Oh, there we go. Okay, so if I can get a little bit of... Yeah. Oh, interesting. So this is something to debug. The markings are indeed... are indeed I'm just trying to get the external view on the windows while I have a little bit of spin on it. It seems like maybe the markings aren't actually stable. That's really weird and surprising. And I definitely will have to look into that. That is odd. I'm trying to think if I'm forgetting something, because there's like a number of different things that are working together to make those markings, which, you know, the windows, that sort of blue area on the ship, and these glowing drives should all be part of that to make them always render on top without any fighting. So it's odd. It's like a problem that I'm seeing for the first time. What could do that? What could possibly be doing that? That is so weird. Let me just revisit some of that code. Yeah. Because this is what I'm doing. I'm putting it in a separate bin, render bin, and then I'm setting the depth offset and disabling depth right. Let me just disable this once. See if this does what I expect. Yep. Yeah, see here with that disabled, everything is flickering. Right? We have Z fighting all the time. Oh, okay. I bet I know what's going on. I bet there still is a duplicate somewhere that doesn't have the marking property. And that's what's causing the flicker. Let's investigate that. So, I have this script that basically does the trip through how the game loads things and loads all the ships into Blender. So sometimes this can kind of sniff out if there are duplicate bits and pieces being loaded. So let's take a look here. Oops. Okay, so this thing isn't picking up any duplicate pieces, so that's a good sign. me just double check that logic. Yeah, in all cases we're setting marking. So there shouldn't be anything different about the rear. I wonder if it... I wonder if it is just... It is actually really a offset issue somehow. Because like if I set this to 0, it's worse on everything. If I set this to 2, yeah. I wonder if it's I wonder if it has something to do with the size and camera distance too. Like there you can see, I just saw a flicker. Like if I get farther away. If I get farther away. So there's... If I go out to like 150, will it still flicker? No. Yeah. That's interesting. So I gotta, basically I've gotta review the markings logic, but basically I think it's the size of the objects. It could also be that something to do with the fact that these markings are on drives, so there's like more transformations that things are being put through. So things kind of aren't ending up quite where I expect them to be. So a little bit more of a depth offset is needed. But okay, let's factor some of this out into some functions that we can reuse and add these to a fighter. And I don't think that there's anything wrong with increasing that depth offset. So I think that's going to be a fine solution, honestly. Yeah, yep. And the reason we're not seeing it in the ship viewer is the ship viewer actually scales things down to be small. So the depth offset is going to be, I think, the way the depth offset is, and the transformations are kind of accumulating, there is going to be different. Something I should actually do is just go through the markings functionality needs more variables. Like it could even just have a depth offset, like tweak parameter that you could set, and then I wouldn't have to hard code it. It could just be something that's like tweaked per ship as needed. Okay, and let's reset this guy back to where he was too. Okay. All right. So, we've got a let's collapse some of this stuff. We've got a module where we have shared functionality. So let's just take a look at how the drives are created. Okay, here I'm just mirroring them. But I can still make a function that kind of makes that drive glow arcs. So we'll just call that drive glow arcs. And we'll just test the refactor with the Hammond first, and then get it into the Rakan here. So basically, all of this stuff is going to be let's see here. Drive glow arcs. So we're going to have all of these things that were constants here are going to become parameters. So radius, thickness, count, and gap angle. We can add an angle offset too at some point, but we'll just keep that simple for now. So radius here is going to be drive glow rad. Count equals arcs gap angle gap, and I think that's it, right? Let's see here. Oh, subs. a little farther into this White Bat audio playlist than I usually get because I'm going a little bit longer today. And it's gone from really driving to really chill. Actually, let's just test our Hammond quick. Yeah, it looks like they're still there, so I think our refactor worked. Let's grab the Rakan. This ship was one of the first that I made, and there's like this weird extra like transformation step that goes on that I need to just factor out at some point because it's not how I make things anymore. And maybe we'll just... Oh, here we go. Some of my favorites. Let's we can do the Oh, why is this? Why is this here? Gosh. Okay. We'll do the drive glow here, and we'll just have to tweak things manually. So dot drive glow arcs, and we'll just put these constants right in here for now. I mainly just want to get something in the game, see how it looks, and then I can refactor this later. Okay, so this definitely should be pretty small. All of my units here, by the way, are in meters. And let's do... Two subs equals, let me see, engine subdivisions is 12. Nice. Yeah, so that does divide. Let's just see what this looks like. And then glow VC is going to be a similar kind of thing. And I'm going to try a more aggressive color here. We want this to be something like a little bit brighter and a little bit more green. So we'll try that. VC, and then I think, yeah, here they're called drive R and drive L, and there's no flip over, but we have left-right symmetry with 6 subdivisions, so we don't need to worry about that. We just need to do the parenting and setting the length. So actually, enough of this is going to be reused that I'm just going to start by copying this. So this will be, actually, let's just change this here too. Let's see. It's facing, and then instead of 1, 0, we'll have the side in R and L. So parent is drive side. And then let's take this as an opportunity to pull some of this stuff out here. Drive len equals 6. But this is before the scale. It is so dumb. I really need to work this out. Actually, transform, yeah. So it's just 0.75. That should work. And slow. Okay. Let's see what it looks like in our workbench. And then we'll update the game logic. I'm sure I've forgotten something here. Oh. Ah. How are my subdivisions 0? Engine subdivisions. Oh, I know. That's like the interior subdivisions, I think. Yeah. All right. Let's forget about doing 6 subdivisions. We'll do, well, actually, we can do something here. We can just make this number bigger. We can just set this divided by 6 plus 2. I think that should work. No. Okay. This is interesting. Where are my... Where am I getting a division by angle by 0? Arc. Circle point. Yeah, okay. See, no, that's fine. Because we should be adding one here. So... Arc. Arc double. Is subs really 0 here? It is. Oh. Oh, 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 oh. Okay, it's not clear to me how the Hammond was working. Maybe... Ah, okay, yeah. That's that. I did have that right, so I can't. Ah, yeah, okay. I'm already dividing by count here, so I don't need to divide by count outside. That's what it was. Okay. Just get rid of this nonsense. Subs 2, 2, 2, 2, 2, and it should be adding an extra point, so we're good. There it is, and we should see those markings. They're a little bit too wide, so they need to be pulled in a little bit. We're kind of eyeballing things here for this one. But they seem to be in the right spot otherwise. About the right thickness. Maybe. A little bit too thin. I was right. First this. Ooh, this is gonna look great. I can't wait. Okay, let's export this. We've got the marking, we've got the glow vertex colors. And just while this is in here, let's go in and get rid of this debug stuff. This was a really fun part to build. I did on another stream, and I'm pretty proud of how it turned out. Whoops. Commented out the completely wrong things. I'm not actually invoking this anywhere, so I can stay. And whoop. And why is this complaining? Multiple exterior loops. Yeah. And see, that's, yeah. Whoops. There's just a view mesh here somewhere. In here. Look at that. Oh. Okay. So now we just got to update the YAML. almost done here. And we just need to update these. All right, should we see if it works? Oh, interesting. Those are totally not in the right place. Interesting. Let's see. That could be a parenting issue here. I'm inclined to think that that's what this is. I really need to revisit this logic because I find myself really struggling sometimes to understand. There we go. Yeah, to remember sometimes. Now see, what I can do at some point is I can have like the front arcs kind of be a subset. Let me just actually, let's do that quick. Let's just do that quick. So for the front, yeah, why not? I was planning on staying up late working on this, so we need a little bit of extra logic for the front. So, oh, this is a nice one. Okay, so what we want to do is we want to actually update our mesh here, depending on what situation is. So if facing equals front, then we want to subset. I think I have. Equal mesh select dot. Actually, we could slice it. So if we're on the right side, we want to, we're on the right side, we want to keep everything to the right hand side of 0. So slice normal equals u dot x hat else slice with mesh. We'll slice the mesh to place normal by dot 0, and then we have to rebuild these, so we'll just move this inside the loop here. So basically we'll just rebuild this every time. Let's see, cur and cur. Let's run the bench, see if this looks like what we expect. And actually, let's just visualize this so we can see if we're seeing what we expect here. Preemptively debug here, and we'll print side facing. So side front, let's see here. Side right facing front. Yep. Side right rear. Side left front. Let's see if this looks right here. It does. All right. I think we did it. So let's export. Okay. Run our ship viewer. Oh yeah. Yep. Nice. All right, let's take her for a spin. I'm curious to see if we run into the same issues here that we did with the Hammond. I don't think we will, because I'm next to positive that's a normal, not a normal, a depth offset thing. So I really have to review that markings logic, because I thought that what I came up with was pretty foolproof, but I guess not. Okay, so make sure that we're back to our normal config here, and mission 1 we'll switch back to the Rakan variant and tests. There it is. Oh, and there's the flicker. Interesting. 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 Okay, so our temporary fix is going to be... Did I close that? Okay. Our temporary fix is going to be setting the depth offset to 2. Oh yeah. Oh. Still a little bit of flicker. What a bummer. I think we could actually go pretty high with the depth offset here before there was really any negative effect to running it. I think another thing that could be going on here too is it just has to do with how I'm stacking transforms on the ships, and that really should be reviewed, because it doesn't make the most sense the way I'm doing it right now. There's definitely better ways to do things than what I'm doing, so oops, back. Okay. But overall, that's a nice effect. And especially interpolating between sort of a range of brightnesses. A range of brightnesses with the different accelerations and stuff would be a good thing to do. And that's the excuse that I needed to kind of rework how I'm doing emissive materials. So we'll because I want to redo radiators the same way. I want to have the radiators kind of react to things as well. And that's imminently doable. Well, let's take one last look at what we did in the ship viewer. So some nice glowing drives for the Rakan, and for the Hammond. That looks pretty cool. Pretty cool. I love the way the emissive materials look in the shadow and in the dark sides of things. It's just such a simple effect, right? But it really just adds a lot. The radiators are emissive too, right? They have some diffuse, I believe, but oh, actually, yeah, that's another reason, is I want to review exactly what I have on these for diffuse, because I don't necessarily want whatever is on there for diffuse. But awesome. Well, I think we made some good headway. A lot of viewers today. Thanks everybody for tuning in. I'm probably going to try to do another stream a little later this week with more work. I'm still pressing on with the 3D printing stuff, so we'll be doing that. And I've got some Star Wars toys to look at either later this week or next week. I might do a little stream about some of that. So, well, thanks everyone. Thanks again for tuning in, and I hope you have a good night. Bye.